This is John Bateman from NOAA Satellites Public Affairs. The Ghost Team Media Day will begin shortly. We just want to give everyone a couple more minutes to join the briefing, and then we will start. Stay tuned. Day in about 1 minute at 1:03 Eastern. We'll be right back with you. All right, good afternoon, everyone, and thank you for joining this virtual media day for the upcoming launch and mission of NOAA's GOES-T satellite. I'm John Bateman with NOAA Communications, and I'll be moderating today's briefing. If you have any additional questions after the conclusion of today's media day, my colleague John Leslie and I can both be reached by email at nesdis.pa@noaa.gov, and I will spell that. That is NESDIS.PA@NOAA.gov. John Leslie's contact information is also included in the media advisory. Today's briefing will feature a short introductory video highlighting GOES-T's journey to Florida ahead of its final preparations before launch. Then experts from NOAA, NASA, Lockheed Martin, L3 Harris, and United Launch Alliance will provide their perspectives on the technology and partnerships that are critical to this mission, as well as discuss the benefits GOES-T will provide once in operation. Lastly, our experts will be on hand to answer questions from the media during our Q&A session after their presentations. For now, though, let's watch this video that shows the teamwork it takes to ship a satellite that is the size of a small school bus from its home at Lockheed Martin Space in Littleton, Colorado, to NASA's Kennedy Space Center. I hope you enjoyed that presentation. With that, I will now introduce our experts who will be presenting today. Our first expert is Pam Sullivan, the director of NOAA's GOES-R program. Our second presenter is Dan Lindsay, the program scientist for NOAA's GOES-R program. Next will be Jim Yo, the chief administrator for the Joint Center for Satellite Data Assimilation, followed by Candace Carlisle, the GOES-R flight project manager at NASA Goddard. Our next presenter will then be Jagdeep Shergill, the GOES-T program manager from Lockheed Martin. Then Larry Crawford, the Advanced Baseline Imager program manager from L3 Harris Technologies, will speak. Following Larry will be Scott Messer, the program manager of NASA's launch services at United Launch Alliance. Next will be Rex Engelhardt, mission manager with NASA Launch Services program. And finally, we will hear from the director of NASA's Joint Agency Satellite Division, John Gagosian. We will now kick off the presentations with Pam Sullivan from NOAA. Pam.
Thanks, John. And thank you all for joining us to hear about the upcoming launch of our GOES-T satellite. NOAA's geostationary satellites provide the only continuous coverage of weather and hazardous environmental conditions in the Western Hemisphere, protecting the lives and properties of the 1 billion people who live and work there. The observations from these satellites are even more critical now when the U.S. is experiencing a record number of billion-dollar disasters. GOES-T is the third satellite in the GOES-R series, which is NOAA's newest generation observing system. The GOES-R satellites are bringing advanced new capabilities to help forecasters better monitor and predict dangerous environmental conditions like hurricanes, thunderstorms, floods, and fire. Compared to the previous generation, GOES-R satellites deliver 60 times more imagery, and they have a new lightning camera to track severe storms that spawn tornadoes and damaging winds. GOES-T is part of a multi-generational family that began with the first geostationary weather satellite in 1974, and it will continue its operation into the 2030s. To ensure these critical observations continue after that, NOAA is now planning its sixth generation geostationary observing system called GeoXO, which will operate into the 2050s and provide even more advanced observations of the weather and environment. GOES-T was developed by a team of people from NOAA, NASA, industry, and academia. It continues the decades-long NOAA-NASA partnership to get the best technology into space for accurate, up-to-the-minute forecasts and for long-term climate monitoring. Our primary industry partners for the GOES-R system are Lockheed Martin, which developed the Spacecraft, the Lightning Mapper, and Solar Imager, and L3 Harris, which built the main camera, the Advanced Baseline Imager, as well as our operational ground system. GOES-T carries 3 additional instruments that help monitor space weather conditions. They are a particle flux sensor built by the Assurance Technology Corporation, a solar irradiance monitor from the University of Colorado, and a magnetometer developed by NASA's Goddard Space Flight Center. GOES-T will be launched on an Atlas V launch vehicle built by the United Launch Alliance. I'll now hand you over to our GOES-R program scientist, Dan Lindsay.
Thank you, Pam. The weather and science communities are very excited to begin working with data from GOES-T. After launch, GOES-T will be launched into the 89.5 west center position, which is over the center of the US, and it will remain there for approximately 2 months where it will undergo post-launch testing. After that, it will be drifted to the west out to about 137 west longitude, which is over the East Pacific Ocean, and from that location, it will continue its post-launch testing for really the rest of the calendar year or so. And then the plan is for in early 2023, GOES-18 will replace GOES-17 as the GOES-West operational satellite. One of GOES-18's most important jobs as GOES-West is for fire detection. As everyone has heard, the fires have been very active across the western continental US, and so GOES-West is in an ideal position out there to get a really close look at those fires. Its Advanced Baseline Imager, or ABI, is ideal for detecting the thermal signature or the hot spots from the fires. And sometimes it's even able to detect the fires before they're reported from the public. This is really critical information to get to firefighters so that they can take care of the fires before they become out of control. The ABI can also track the smoke from the fires in order to alert forecasters on when the smoke plumes are entering major cities. Another really useful application from GOES West is for the aviation industry. If you've ever taken a flight from North America to, say, East Asia, you have likely gone over the North Pacific Ocean, and this is the same area that GOES West monitors. There are aviation hazards out there, for example, volcanic ash erupting from volcanoes in the Aleutian Islands, atmospheric turbulence, which the ABI is able to detect, as well as lightning from thunderstorms, which we're able to detect from the geostationary lightning mapper. One recent thing that we learned from both GOES East and West that we didn't know previously is these instruments, the ABI is able to detect pressure waves from volcanic eruptions. I'm sure you all heard about the Tonga eruption, which happened a couple of weeks ago, the volcano near there. There was, you may have seen a movie of a pressure wave moving out and circling the globe multiple times. That was actually taken by taking differences between successive images on GOES 16 and 17's ABI. Next, I'm going to hand it off to Dr. Jim Yo from NOAA's National Weather Service.
Thank you, Dan. As the operational GOES West satellite, GOES-T will be vital for achieving NOAA's weather-ready nation goals, helping to save lives and to protect property and resources. GOES-T will help improve NOAA's numerical weather prediction models, which are used by National Weather Service forecasters, by providing measurements of wind speed and direction at different levels in the atmosphere and other data that will be assimilated into those models. Since many of the weather systems over the United States move from west to east, GOES-T, as GOES West, will improve model forecast for the entire country. The GOES-T imager and lightning mapper will be used for making warnings and forecasts of significant weather events, including severe storms, hurricanes in the eastern Pacific, including those near Hawaii, atmospheric rivers that bring significant rain, and related hazards such as flooding and landslides to the western United States, and wildfires. Finally, GOES-T space weather sensors will provide observations that will enable the National Weather Service Space Weather Prediction Center to detect and issue warnings for solar storms that can threaten critical power, communications, and navigation systems. In sum, directly and indirectly, GOES-T will help citizens, industries, and local, state, and federal agencies make informed decisions and take proper actions before, during, and after high-impact weather events. And I'll hand off to the next speaker, Candace Carlisle, the GOES-R Flight Project Manager.
Candace, you're muted. Please check your microphone. Candace?
Sorry, I thought I had that. Let me start again. NASA Goddard is responsible for the GOES-R series satellites and instruments. To give you an analogy of what that's like, it's like you want to remodel your kitchen and your sister is a general contractor, so you bring her in to help you out. She works with you to figure out what needs to be done, brings in the electrician, the plumber, does a little bit of the cabinetry, and then makes sure you have a really great kitchen at the end. Likewise, NASA's GOES-R team works with NOAA to determine the requirements. We contract with companies such as Lockheed Martin and L3Harris to provide the satellite and the instruments, and we oversee their work. Goddard also built the GOES-T magnetometers in-house that will provide more accurate measurements to help predict space weather. We also have the GOES-R Mission Operations Support Team. They completely check out the GOES-T spacecraft on orbit, and then they hand it over to NOAA for operations. And then that support team provides engineering support throughout the life of the mission. Next up is Jagdeep from Lockheed Martin.
Thanks, Candace. From building the first ever weather satellite to building NOAA's current GOES-R series, we here at Lockheed Martin are passionate about supporting our customers' mission, especially as climate change drives interruptions in current weather patterns. In the life of GOES-T, there were years of design and development and hardware build, followed by integration of all that hardware and software into the spacecraft. And it was capped off with a rigorous test campaign to ensure that GOES-T is really ready for space. We completed the last 2 years of GOES-T's integration in Littleton, Colorado during this global pandemic. Our team shifted seamlessly to a hybrid work environment, ensuring personnel safety as our #1 priority. And I'm happy to say the team was still able to deliver this critical satellite for our customer. I'm so very proud of our Lockheed Martin team for getting us here safely. In addition to designing and building the GOES-T spacecraft, Lockheed Martin's Advanced Technology Center in Palo Alto, California provides 2 of the instruments on the GOES satellites. The first ever geostationary lightning mapper, better known as GLM, as well as the Solar Ultraviolet Imager, or SUVI. Once GOES-T was fully assembled with its instruments, we subjected it to the environments it will experience in space. Vibration and acoustic testing simulated the ride the spacecraft will have on the rocket as it launches into space. And thermal vacuum testing simulated the extreme hot and cold temperature swings it'll see in the vacuum of space during its mission. After we successfully completed this rigorous test campaign, we shipped the spacecraft here to Astrotech Space Operations in Titusville, Florida in November of last year. In Florida, Lockheed Martin, Astrotech, and United Launch Alliance worked together alongside NASA's launch services provider to get the spacecraft ready for launch. This includes things like final testing, fueling of the spacecraft, and encapsulation with the fairing. This launch is truly the culmination of years of hard work by a huge team of engineers from Lockheed Martin, NOAA, and NASA, as well as countless other teams. We are so honored to help bring forecasters the data they need to save lives when it's needed the most. And speaking of groundbreaking data, I'd like to throw it over to from L3 Harris more about advanced planning.
L3 Harris has multiple roles on the GOES satellite system. We provide the primary instrument on the GOES-T spacecraft, the Advanced Baseline Imager, or ABI. The imager is assembled in Fort Wayne, Indiana, and our environmental testing is performed at our L3 Harris facilities in Rochester, New York. ABI images the Earth using 16 channels. It provides 3 times more spectral information, 4 times the spatial resolution, and 5 times faster coverage rate than the previous GOES imager. As you've already heard, it's used for a wide range of applications related to weather, oceans, land, and climate hazards such as fires, volcanoes, floods, hurricanes, and severe storms that could possibly spawn tornadoes. The L3 Harris team also provides support during spacecraft integration and test campaigns and provides operational support for all on-orbit assets. Our L3 Harris Enterprise ground system operates from 2 primary locations at the NOAA Satellite Operations Facility, or NSOF, that's in Suitland, Maryland, and the Wallops Command Data Acquisition Center at Wallops, Virginia. There's a 3rd operations facility at Fairmont, West Virginia, and that serves as our consolidated backup in case of a systems communication failure at either or both NSOF and Wallops facilities. Satellite data is received at Wallops and the backup facilities leveraging 6 L3 Harris 16.4 meter tri-band antennas, and 3 of those antennas are installed at each of those sites. Now I turn it over to Scott Messer, who will discuss the role of United Launch Alliance.
Thanks, Larry. And on behalf of United Launch Alliance, I just want to say how excited we are to be here as we prepare to launch GOES-T for NOAA in collaboration with NASA. The Atlas V rocket is currently being processed in preparation for launch. The team began stacking the vehicle in our vertical integration facility yesterday, and the first stage was successfully stacked yesterday, and today we've added one of 4 solid rocket motors that will help propel GOES into orbit. On Saturday, we will stack the 2nd stage on top of the vehicle. Meanwhile, over in the payload processing area, we are preparing and working with the GOES spacecraft in preparation for encapsulation of the spacecraft inside the payload fairing. And then on the 15th of February, we will mate the encapsulated spacecraft onto the top of the vehicle. Once the rocket is fully stacked, we will perform a series of integrated operations and tests and final preparation for launch. We are certainly proud to be and excited to be at this stage in the processing and look forward to another launch of a GOES satellite. ULA and our heritage launch vehicles, Atlas and Delta, have launched every GOES satellite that's ever been launched, including the revolutionary GOES R and S spacecraft, which launched on the Atlas V rocket. The first GOES satellite was launched on a Delta rocket in 1975. The rocket being processed out at the pad is an Atlas 541 configuration, and it'll deliver GOES-T into an optimized geosynchronous transfer orbit. This orbit is designed to place the spacecraft closer to its final destination and conserve the satellite's fuel supply for a longer mission life. The vehicle has a 5-meter fairing and, as mentioned, 4 solid rocket motors. And when it's fully stacked, it will be 196 feet tall. It will weigh close to 1 million pounds, and at liftoff will produce more than 2 million pounds of thrust. This will be ULA's 149th launch and our 22nd launch in partnership with the NASA LSP. It'll be Atlas's overall 92nd launch, and Atlas V has demonstrated 100% mission success for all of our customers on all of our launches. And so with that, in closing, I'll just say thanks to our mission partners. The entire ULA team is looking forward to another successful launch of a GOES satellite. And now I'll turn it over to Rex Engelhardt, the mission manager from the NASA Launch Services Program.
Good afternoon. This is Rex Engelhardt, and I'm one of the mission managers for NASA's Launch Services Program here at Kennedy Space Center. We consider ourselves Earth's bridge to space for NASA. We procure and then provide the launch services for all the NASA spacecraft that launch. Our charter is to not only procure the launch vehicle, but to get in between the spacecraft and the launch vehicle and help them in the integration of the spacecraft onto the launch vehicle. And in the meantime, we're also procuring the ground processing facilities that they will need at the launch site to do final processing of the spacecraft. And then we have a highly experienced launch team that steps in and helps with the launch campaign. My job as a mission manager is to lead that team. I've had the pleasure of being the lead for GOES-S, and I'm also working GOES-U, which is the next and last one of this 4 spacecraft GOES series. I can't say enough about the team that we've been working with. We have NASA Kennedy Space Center, NASA Goddard, we've got NOAA, we got Lockheed. Those are the primary people involved with the integration of this spacecraft onto the rocket. That all launches as a system. It's all one system when it launches. So the integration phase of this, in this case, we did it fairly quickly in about 2 years. It's critical to do that and make sure that it all works well together when the launch occurs. As Scott just mentioned, things are going well with the ground processing right now. The rocket, they put the first stage up yesterday, and they'll be testing that next week. And while they're doing that, they'll be encapsulating the spacecraft over at Astrotech and getting ready. After that, then a week after that, we'll make the spacecraft to the rocket. And the week after that, we'll do the final closeouts and take the covers off all the instruments, make sure everything's clean. And then we'll do the launch, which I'm sure will be successful. Finally, the last person that's going to speak today is going to be John Gagosian, and he's the director of NASA's Joint Agency Satellite Division.
Thank you very much, Rex. As you said, I'm John Gagosian, director of NASA's Joint Agency Satellite Division. Our division is part of NASA's Science Mission Directorate, and we manage, on NOAA's behalf, the development and deployment of operational weather satellites like GOES-T. We've partnered with NOAA for more than 50 years on the nation's terrestrial and space weather satellites in polar, geostationary, and libration point orbits. Our partnership has been very successful, having significantly advanced the nation's Earth observation capabilities to improve weather forecasting, severe storm and hurricane prediction, and climate observations. And over the years, the NOAA-NASA partnership has successfully deployed more than 60 weather satellites. As you heard from Candace, NASA is responsible for the formulation, development, launch, and initial operation of the GOES-T satellite. NASA and NOAA are committed to the continued success of the GOES-R program and its final mission, GOES-U, set to launch in 2024. In addition, as Pam indicated, we're moving forward in the formulation of the follow-on program known as GeoXO. Our teams have established collaborative working relationships and are striving to meet the weather and environmental monitoring requirements of the US and the world. I'm confident that our partnership will continue to be strong and successful. And now I'll turn it back to John Bateman.
All right, thanks so much, John, and everyone else. Now we will open the briefing to questions from the media. To ask a question, please find the Q&A box located at the bottom right of your screen. Type in your name, affiliation, your question, and the specific expert you would like to answer it if possible. We will wait for some of those questions to come in, but we already have one. So I will read that off now. This question is for Jim Yo. Jim, the question is, how will GOES-T help with things such as forecasting wildfires and atmospheric river systems that are such a problem in the Western U.S.?
Thank you, John. I'm delighted to address this question, or it's two questions here that I'll take in turn. I'll start with the question of wildfires, because it's almost impossible to overstate what a significant factor GOES-T will be in the forecasting and responding to wildfires. In the first place, the imager for GOES-T monitors the land surfaces, including the vegetation health. That gives us a background information, an outlook, if you will, for the potential for wildfires to occur. So even before a wildfire is happening or likely to happen, we have some idea of where to be looking. The lightning mapper, because lightning is one of the potential sources of ignition for wildfires, especially in areas where there aren't people, will give us ideas of or locations where potential fires could be ignited by lightning strikes. Dan Lindsay talked about how the thermal imagery of the imager can be used to detect hot spots and the ignition of fires once they've occurred early. That helps us deploy resources for fighting fires and to move people from harm's way as quickly as possible. And he also talked about the smoke trails, where we can see the impacts on citizens living far away from the fires who need to be protected from air pollution and whatnot. Finally, afterwards, after a fire has occurred, we're still looking at the Earth's surface. We can see burn scars. For years after, we can monitor the recovery of areas impacted by wildfires, how that might impact flooding and other industries such as forestry for years to come. So before the fire happens, while it's happening, immediately after, and way after it occurs, the data from GOES-T will be helping to make informed decisions and take proper actions. Atmospheric rivers, of course, where we can look at the cloud imagery from the Advanced Baseline Imager that will help us see the formation of atmospheric rivers coming from the Pacific Ocean to the West Coast. Typically, we'll be able to have some knowledge about the size of them, how wide they are. We'll be tracking the winds that are pushing them, and that in turn tells us how quickly they'll arrive. We'll use that information in combination with moisture soundings from microwave sensors on NOAA's polar satellites in order to get an idea of the quantitative precipitation amounts that will be brought to bear there. Thank you.
All right, thanks so much, Jim. The next question I think I can take a stab at. This is from Joe Whitty from Aquint. He asked if there's a website address with images and video for GOES-T. Yes, Joe, there is. Probably the easiest thing to do is check out the link that is in the bottom left-hand box on your screen. You should see it there to the bottom left. There's a link for the media advisory page, and the link to the GOES-T webpage is located in that media advisory. If you have any issues, just let us know. We can you can reach out to us by email and we'll send that to you. But to everyone, that media advisory link in the bottom left should have that link for you for GOES-T. All right, next question we have. Let me go up to here. Our next question is from Marcia Smith. Marcia asks, what was the root cause of the ABI degradation on GOES-17 and how was it fixed for GOES-T? And I'm thinking, Larry, can you field that one? And if so, you may need to take yourself.
Yes. The investigation on GOES-17 determined that the most likely root cause of the thermal performance that you're referring to was caused by foreign object debris, or we refer to it as FOD, blocking flow of coolant in our loop-heat pipe system. For GOES-T and GOES-U, changes have been implemented to eliminate that. Basically, the hardware that was at fault, or we determined was most likely cause for that FOD, has been eliminated from the design, and basically that design's been thoroughly reviewed and extensively tested.
All right, wonderful. And then this was actually a two-part question from Marcia Smith. This one maybe, Pam, you could answer. What is GOES-17's future? Is it going to be decommissioned?
Yeah, thanks for that question. The GOES-17 is still a very capable satellite. The Advanced Baseline Imager is still delivering more than 90% of the planned data, and all the other instruments are
Okay, I think we lost your audio there, Pam. Are you still speaking? All right, we may come back to that. We may come back to you again, Pam, for that in just a second. In the meantime, though, we do have another question from Jeff Faust from Space News. The question from Jeff is, are there any improvements or any other changes in the GOES-T launch campaign versus GOES-R and GOES-S? Good question. This one could be for Scott or Rex. Who wants to take this one?
So this is Scott. I'll take this real quickly. So the biggest change that we've made is with each successive GOES satellite, we have gone through a process of optimizing the trajectory that we fly in order to provide a better injection orbit to allow more spacecraft life. And I think in this, for example, in this case, we were able to do something that gave the spacecraft another 4 or 5 years worth of lifetime. So Jeff, that's the biggest change that we've made. Other than that, it's very similar to what we did on the other ones.
All right, thanks so much, Scott. We're going to go back to the question we had before about from Marcia Smith about GOES-17's future. I believe John Gagosian was going to be able to answer that for us. John, are you there?
Yeah, I'm here, and if Pam's not back on the line yet. So GOES-17 will be moved into an on-orbit spare configuration. So it will be available as needed in the future as a backup.
Wonderful, thank you. The next one, I'll let anyone who feels they could best answer this to answer it. This is from Marcia Dunn from AP. What is the cost of the satellite itself, and how is GOES-17 holding up, and can it keep doing its job until next year?
So John, this is Pam, I'll take that. So sorry for the internet foibles. So we don't typically price the satellites one by one. The total cost for the program, which includes all 4 satellites, the ground system, and 30 years of operations, the total life cycle cost is $11.7 billion, which is a significant investment, of course, but it does that value is returned to the U.S. public in the benefits that's provided. More than a factor of the investment.
All right, thank you. Next question from Rachel Dunn. I'm sorry, were you finished, Pam? Next question from Rachel Dunsing, WNCN, Raleigh, North Carolina. The question is, GOES-T will become GOES West once operational. So please explain just how improvements in weather satellites over the West Coast will help improve numerical weather prediction for the entire country. Who'd like to take this one?
I think this is a question for me. This is Jim Yo from the National Weather Service. As I mentioned in my opening remarks, a lot of the weather systems over the continental United States tend to move from west to east. So we think of the west as being upstream and the east as being downstream. So if we're able to look at the conditions over the Pacific Ocean and over the western United States, those contain the seeds of the weather that's going to evolve into from today into the weather over the eastern United States in 3-5 days or a week. Likewise, our GOES East gives data that benefits our partners in Europe, for example.
All right, great. Thanks so much. And I'm sorry, I wanted to revisit the second part of that question that we may have not had a chance to do that. The second part of the question we had before was about, can GOES 17 keep doing its job until next year? And Pam or Candace, would either one of you like to take that?
Yeah, hi, this is Pam. Yes, GOES 17 is operating currently for us, and we don't expect any significant change in the performance for the next year while we're checking out GOES-T.
All right, wonderful. Let me see if we have any other questions coming in. All right, I believe that is all the questions that I am seeing so far. Is that correct? And just one more reminder, before we wrap it up, if there is anyone who does still would like to ask a question, or does still want to ask a question, I should say, you can please find the Q&A box located at the bottom right of your screen. Just type in your name, affiliation, your question, and the specific expert, if possible, that you'd like to answer it. If we don't have any more, I can start wrapping this up. Okay. We do have one, it looks like here, from Marcia Smith, again, from Space Policy Online. Dan, maybe you could answer this one. It looks like, what surprised you about ABI's ability to detect the pressure waves from volcanoes?
Hi, Marcia. Great question. So several things surprised me. I would say number one was not so much the satellite detection, but more so the fact that a volcanic eruption could be so powerful that it could have a wave that would travel around the Earth multiple times. And I believe it was even detected something like a week after, and as it became weaker and weaker with time. That in itself to me was unbelievable. I don't remember a volcano like such as that in the past. I know there was the Mount Pinatubo eruption back in 1991 in the Philippines that was extremely powerful as well. And of course, most of us are familiar with the Mount St. Helens eruption in the US in 1980. But in terms of the GOES 16's ABIs detecting the pressure wave, we don't have these things happen very often. And so we just haven't had the chance, I guess, or the opportunity to try to detect such a thing before. And so scientists used the data and started looking carefully at it. They filtered it. They took time differences. And you know, after only a few hours, the scientists were able to sort of extract that signal and make maps of it. It was all over social media. So really just quite an unbelievable event.
All right, thanks so much, Dan. And I believe, okay, I'm sorry. We do have another question that's coming in, again from Rachel Dunsing from WNCN. She asked, how long from once GOES-T gets into orbit will we start seeing imagery from it? Who would like to answer that one?
So John, this is Pam. So our current plans are for the first light imagery, as we call it, to be available in May of next year. That won't be operational, but that's the first images that we get after we go through the outgassing phase, open the doors, and take the first checkout pictures. So that's in the May timeframe. We expect by July that the ABI data we expect to be flowing in a non-operational sense to the weather forecasters. But this is something new that we're actually doing for GOES-T, where we're making the data available early to weather forecasters during the checkout period so that they have the benefit of the extra imager on board. And that's again in the July timeframe.
All right, thank you. Looks like we have another question from Marcia Dunn, AP. For Dan, maybe you can answer this one again. How much better would the data have been if GOES-18 or GOES-T had been observing the Tonga eruption versus the current GOES?
So the answer is it would have been very similar, maybe slightly better. If you looked carefully at lots of different channels from the GOES-17 ABI of the eruption, there may have been a few stripes, a little bit of, I guess, noisy data. That's the effect of the anomaly, but really quite minor. With GOES-18, that will be absent. And so I would say the answer is slightly better, but not noticeably so.
Okay, great. Thanks so much, Dan. I believe that is the last of our questions. I don't see any more coming in. Oh, I'm sorry. As soon as I speak, it looks like we're getting some more. All right, this is from Stephen Clark from Spaceflight Now. The question from Stephen is, how many GOES satellites are currently in NOAA's fleet?
Yeah, John, this is Pam. We have 2 from the GOES-R series that are on orbit, and then there's 2 from the previous generation that are also in operation, in on-orbit storage for us right now. So 4 total. And then there is another spacecraft from the previous generation that we have actually given to the U.S. Space Force, and they are currently operating that over Asia.
All right, thanks so much, Pam. And now, let's see. All right, I believe that was the last of our questions. We are going to start wrapping up Media Day if that is the case. I want to thank all of our presenters and participants for joining us today for NOAA's GOES-T Media Day launch. A recording of this media briefing will be available later today, by the way, for those of you looking for it. It will be on the online media advisory on NOAA.gov, as well as on NOAA Satellite's YouTube channel. Now, if anyone from the media has additional questions or informational needs, please feel free to reach out to John Leslie and myself. Again, I'm John Bateman, at our email address, and I will say it and spell it one more time. That is nesdis.pa@noaa.gov. That is nesdis.pa@noaa.gov. And once again, our contact information is also available in the media advisory. Thanks so much for joining us, everyone.